In this video, I'm going to show you guys 3 slightly harder, slightly trickier integrals, and we still have to use the U substitution for them. And did you guys notice that I'm going to be using this black and red marker for all these integrals? This is so cool, the new marker by Expo, the 2-in-1 version. Okay, I will have the links down below in the description so you can check them out as well. They have different color combinations. And thanks to our math department chair, Sherry, for this wonderful, amazing, surprising gift. I'm so excited to use it because I've never seen anything like this before. And you guys will see how this marker works on the whiteboard in this video. Okay, so let's get to it. First one, the integral of x over 1 plus x to the 4th power dx. What shall we let the u be, right? If we let u be the denominator, 1 plus x to the 4th power, du will be 4x to the 3rd power. However, on the top, we only have x to the 1st power, right? In that case, we know they won't cancel each other out. Well, that's not the right choice for you then, right? Well, we do have this x on the top. I want to cancel with that x. In that case, it will be great, right? So u should be what? So that we can cancel this x to the 1st power. Well, this is x to the 1st power. I want to let u equals to something with x to the 2nd power, because once I differentiate that, I get something x to the 1st power, isn't it? Okay, I want to produce x to the 2nd power somewhere in this integral. And the place is going to be right here. Let me show you. Okay, I'm so excited. Alright, so this is going to be the integral. On the top, I'm just going to let it to be x. And on the bottom, we have 1 plus. Instead of this x to the 4th power, let's look at this as x squared and then square. How's that? So I'm going to open a parentheses. And you see, I'm going to just switch the marker like this. This is so cool, huh? Inside here, I will put down x to the 2nd power. And then this to the 2nd power, so that this is still the 4th power, isn't it? This is just so cool. And now what? Well, as our strategist earlier, I'm going to let u equals to x squared right here, so that when I differentiate it, I get du is equal to 2x dx. Same old business, let's divide 2x on both sides so we can isolate the dx. So we get dx equals to du over 2x. And now we can take this integral from the x world to the u world. And now we will see this is going to be the integral x on the top over 1 plus. And notice that I only let u equals to x squared because inside here we only have x squared. That's the inside function, right? I cannot say 1 plus x squared. Okay, so that's very different. Therefore, we still have the 1 plus right here, and then the inside u, this is x squared actually. X squared adds the u. Okay, I'm going to change that. It was x squared, and now it's going to be the u, and then we still have that to the 2nd power. And then for this dx is du over 2x, so let's put that down. Du over 2x. Very nice. So that we see this x and that x cancel each other out, huh? And then we are just going to be integrating 1 over 1 plus u squared du. And now, what's the... Well, I forgot something. 1/2. So let's put a 1/2 in the front. Okay, what's the integral of this? 1 over 1 plus u squared. It's the inverse tangent u, right? So we still have this 1/2 right here. Inverse tangent u. At the end, take this back to the x world. So u is x squared. So we have 1/2 inverse tangent. Inside here is the x squared. And then we are done. So put plus c. This right here is it. Really cool, isn't it? Okay, for the second one, we have the integral of tangent x times ln of cosine x. As usual, I like to tell you guys, okay, maybe we let u is equal to the inside function. However, in this case, if u is equal to cosine x, the derivative of cosine x is negative sine x, and here we don't have a sine x. This is what? Tangent x. So they don't cancel each other out right away, right? Maybe it will work, maybe not, I don't know. But here is the secret. instead of letting u equals to cosine x, I'm going to let u equals to ln of cosine x. And let me show you why I choose to do that. So u equals to ln cosine x, and I'm going to differentiate this for you guys. You will see du is equal to, and now remember how to differentiate with the ln function. The derivative of ln of something is going to be 1 over the inside, right? And the inside stays the same for now, so we have cosine x. But don't forget, the chain rule says we are going to look at the inside and then look for the derivative of this. The derivative of the inside, the derivative cosine x, is negative sign. So we multiply by this, by negative sine x, okay, the chain rule. And we still have the dx. And now I'm going to just rewrite this again. This is du equals to negative. We have sine x over cosine x. So that's what? That's tangent x. So this is negative tangent x dx. And you see, I'm going to divide both sides by negative tangent x. So I can isolate the dx. dx will be du over negative tangent x. And you see now, this tangent x and that tangent x will cancel each other out. Very nice, huh? Alright, take this integral from the x world to the u world. This is going to be the integral tangent x times this part, this right here, it's the u. So I will multiply by u. And then the dx is that du over negative tangent x. And now, tangent x cancel each other out. And we will have what? Don't forget the negative. Bring the negative to the front. Negative integral u du. And how do we integrate u in the u world? Well, this is going to be, add the power, 1 plus 1 is 2. And then divide by 2, which is the same as multiply by 1/2. Anyways, this is going to give us 1/2 u squared. And we bring down this negative. Okay, we are done. At the end, I'm going to rewrite this nicely. We have the negative 1/2 right here. And then for the u, let me open a parenthesis to make everything looks clear. Inside here for the u, which is ln of cosine x, let's put that down here. ln cosine x. And then we are going to raise this to the second power, and we are done. So put plus c. This right here is it. Okay, and one more example for you guys. Okay, for this one, we have the integral of 1 over 1 plus square root of x. We don't have a lot to work with, isn't it? Because it seems like our only choice for the u is the denominator, 1 plus square root of x. And the reason that I want to attach the 1 plus right here is that when I differentiate the whole denominator, the 1 goes away anyways. So that's a good choice. And I'm not sure what will happen, and let's just try our best to make things happen. Let's go. U equals to the denominator 1 plus square root of x, and then I'm going to differentiate both sides, so we get du equals to this is 0. The derivative of square root of x is what? 1 over 2 square root of x, and then we are done with the derivative part, so attach a dx. This time, we are going to multiply both sides by 2 square root of x, so that we can get dx equals to 2 square root of x du, right? 2 square root of x du. And let's just take this into the u world to see what we get. So this is going to be integral 1 on the top over the whole thing right here is u. So I put on the u right here in the denominator. And then for the dx, we know it's this. But there's somebody that's not invited in the u world, namely the square root of x. But the good thing right here is that if you refer back to this equation here, you see u is equal to 1 plus square root of x. Why don't we just subtract 1 on both sides? This way we get what? This way we can see that square root of x is equal to u minus 1, right? So you know this right here is the same as u minus 1. And we can rewrite this again for you guys. This is saying dx is equal to 2. The square root of x is the u minus 1, so I have to use a parentheses. So we have the u minus 1 here and then du. And if I plug in this into the dx, let's see what will happen, right? So let's write down 2 parentheses u minus 1 du. Okay, and now let's continue. A few things that we can do. First, let's bring the 2 to the front. And then we have the integral. U minus 1 goes on the top, right? Over u. And this is du. And now what? Well, I cannot just integrate this u because this u is affected by this u. So we are going to split the fraction. Okay, this is going to be 2 integral u over u. Let me write down all the work for you guys. And then minus 1 over u. We split the fraction. And we know this is just 2 integral u over u is 1. And then we have the minus 1 over u du. And we're ready to integrate. So this is going to give us 2, and let's open a parentheses for the resolved integration. 1 in the u world, the integral for that is going to give us u, and then minus the integral of 1 over u in the u world, that's ln absolute value of u. And then we are done. And now I have to take this back to the x world. We were done with the integration part, right? So I'm going to do 2 steps right here. I'm going to take the 2 and then distribute it inside. In the meantime, we know u is equal to 1 plus square root of x, right? That's what we said to start off with. Therefore, we will have 2 times the parentheses. U is 1 plus square root of x. So let's write it down right here. And then minus 2 times that. So we have 2 right here. And then ln absolute value, the u is 1 plus square root of x. So let's put that down right here. 1 plus square root of x. And we close this absolute value. And technically, we are all done right here. But a few things I'm going to mention in this particular example. First, as you can see, of course, we can distribute the 2 in this parentheses, right? In front of this parentheses. And we'll end up with 2 plus 2 square root of x minus 2 ln absolute value of 1 plus square root of x, like all this, isn't it? All right, and the moment we are done, you can call this to be plus c, but you may find the answer to be different in the back of the textbook if you have this question for the homework. First, you see you have a constant right here, which is the 2. And then when you have 2 plus c, this is a constant. This is also a constant. 2 constants, when you add them together, it is still a constant. So sometimes they may merge into just one big constant c. So right here, I would like to label this as c1. And what you can do is you can ignore the 2, but then just kind of label this as a new c. Just write down the function part, that's all. So let's write down 2, and then we have the square root of x minus 2. And then we have the ln. And now this is another thing I want to mention. If you look at this part right here, we know square root of x, the output is always what? The output of square root of x is always positive. And then we're adding, and this is the positive one. Positive plus a positive, inside here, we are always guaranteed to have something positive. In that case, the absolute value is not needed. Therefore, I can change the absolute value into just a regular parentheses and then put in 1 plus square root of x. All right? And as I said, this and that together, I'm just going to write it as another constant, so plus c, and technically I will label that as c2. However, this is what I'm going to present for the answer. Okay? In that case, I will just write this as the constant that we are going to use. And this right here is it. Okay.
That's it.
Let me know what do you guys think about this black red marker. It's really cool, isn't it?